For two-dimensional arrays, like this one I gave you, say we have here an array num of 2 rows and 3 columns. So how many elements do we have? There are 2 rows and 3 columns. So the total number of elements would be 2 times 3 is 6 elements. Let's say we represent this two-dimensional array of 6 elements using a table of 2 rows and 3 columns. And let's say I is the index for the row and j is the index for the column. Then our I would be ranging from 0 up to 1 and j would be from 0 up to 2, right? So the values of I would be 0, 1, and j would be 0, 1, and 2. So there are 2 values since there are 2 rows. First row would be this one, I is equal to 0 in here. And the second row would be here, I is equal to 1 for the second row. And for the column, this is your j equal to 0 and j equal to 1. And this one is your j equal to 2. So for the first element, this is denoted as num 0, 0, which is this one. Okay. And next is 0, 1, which is this. So take note that the first index is always the row index and the second index is the column index. The third would be num 0, 2, right? Which is this one. And the fourth is num 1, 0, which is this one. I is 1 and j is 0. The fifth one is num 1, 1, and that refers to this one here. So this is I is 1 and j is 1. And the last element, the sixth element, is num 1, 2. And this is referring to the last in here. Your I is 1 and the value of j is 2. So notice that on the first row, the value of I, index I, is 0. Okay, that's the same for all elements in that row. And for the second row, the value of I is 1, which is the same for all elements on that row. For the first column, that is the second index, for the first column, the value of j, which is 0, is also the same for all elements in that column. And for the second, it's 1. And for the third column, it is 2. For two-dimensional arrays, we could order the elements in 2 ways. When you order the elements row-wise, we call that row major order. And the second way is column-wise, and we call that column major. Now for each way of ordering the elements of the two-dimensional array, we have a unique addressing function for the elements. We have 2 indices, I and j. In how many ways could you combine this I and j? You could combine the 2 indices I and j in 2 ways, right? So it's either ij or ji. This ij is referring to the row-wise or the row major, and the ji is referring to the column-wise or column major. Row-wise or the row major means that the primary reference is I and the secondary reference is j. While for column major or column-wise, the primary reference is j, the column index, and the secondary reference is I. So how do we arrange now these 6 elements for our example in row major or row-wise or ij order? So for the ij order or row-wise or row major, the primary index is I the row. And so we would go this way. You choose one row and list all the elements in that row. After that, you move to the next row and list all the elements in that row. And then you move to the third and so on up to the last row. So in that case, considering the first row, we would go from this one, 0, 0. Second is 0, 1. Next is 0, 2. After this row, we go to the next row. So we start with 1, 0. And the next is 1, 1. And the next is 1, 2. Okay? So this list of elements here is the row major or the row wise, or what we call the IJ order, where the position of this is 1 and this is 2, 3, 4, 5, 6, since we have 6 elements. So this is how they are arranged or stored in the main memory. For the column major or column wise or the JI order, our primary reference is the column. So it is column wise, therefore, we proceed from the first column. So this would be listed first and then next. And then after the first column, we move to the next column. So this would be the third and the fourth. And after that, we move to the third column. So this would be the fifth and the sixth. So let's write in here our column major or the column-wise JI order. So the first element would be the same as the row major. The first one is num 0, 0. The second is this one, num 1, 0. So this is the first column where j is equal to 0. And after the first column, we move to the next column where j is 1. So the third would be num 0, 1. And the fourth is num 1, 1. So again, these two elements here are the elements at the second column where j is equal to 1. After the second column, we move to the third column. So the fifth element now in our list would be num 0, 2. And the sixth and the last would be num 1, 2. So again, these last two elements are the elements in our third column where j is equal to 2. So notice that the row major order of the elements and the column major order of the elements are not the same. They may be the same on the first element, the position 1, and also the position 6, but in between the first and the last elements, they're not the same. As I have mentioned a while ago, each ordering has a unique addressing function. This one for row major and this one for column major. And notice that they're not the same. So when you use this addressing function, it will obviously give us different results. Now from our lesson for 1D, the addressing function is L sub O plus C times I minus B, where C is the number of memory words allocated to one element, I the index of the element, and B is the base value, which is equal to 0. So for 2D, since there are now two indices, I and j, the function would be L sub O, which is the same as 1D. L sub O is 1, the lower bound. And since this is row major or row wise, our primary index reference is I, which is the row index. So we say I minus the base of I. What is the base of I in our example? The base of I is 0. This is our B. which is equal to 0, and u is equal to 1. But since there are now two indices, I and j, we denote this as b1 and this one as u1. And for the column index j, the base is denoted as b2 and the upper value is denoted as u2. So this one is 0, this part here, times what is this value? This is simply the number of elements in one row because our primary reference is the row. Now, how many elements are there in one row? If we look at this table, there are 3 elements, right? So, in mathematical expression, how do we get that value 3? Using these variables, the number of elements is simply equal to the number of columns. If we take one row and then count the number of elements in that row, that is simply equal to the number of columns. First column, second, and third column. Now, how do you get the number of columns in terms of B and U? That would be, since this is columns, number of columns, we're going to look at the B2 and the U2. So in terms of these two variables, U2 and B2, that would be U2 minus B2 plus 1, right? This is the mathematical expression representing the number of columns or the number of elements in one row. So that is why in the function formula we have here times u2 minus b2 plus 1, which in the case of our example, that would be u2 is 2, right? 2 minus 0 plus 1, that is equal to 3. Okay, so that's correct. And after considering the row, we consider the next index, which is of course j, because there are only two indices, I and j. So after I, it would be j. You say j minus the base of j, which is b2. That is also equal to 0. So let's try to use this time the addressing function for row major to verify the locations of these elements that we have listed here. So let's try to locate element, say this one, num02, num02. So the value of I here is 0 and the value of j is 2. And from the formula, L sub O is 1 plus the I is 0 minus B1 is 0 times u2 minus b2 plus 1 is, as we have obtained a while ago, it is equal to 3, plus your j is 2 minus 0. And so we simply cancel this one out. That's 0. So this is 1 plus 2, and that is 3. Meaning the position or the location of element num02 in the array structure is third position. So indeed it is, right? For the column major or column wise ji order, the addressing function is given as L sub O plus, now this is column wise, so our primary reference now is the column, and so we use here the column index j, while in here the column index I. So this is now j minus the base of j, which is b2, times this expression represents the number of elements in one column because this is column wise. Now why is that u1 minus b1 plus 1? The number of elements in one column, if we look at our table here, number of elements in one column, take one column, say this one, j equal to 0, and count how many elements are there. It's 2, right? And 2 is simply equal to the number of rows. So how do we get the number of rows? From these variables b1 and u1, which are the base and the upper value for our row index I. It would be the upper, which is u1 minus the base plus 1. So this mathematical expression here represents the number of rows, which also is equal to the number of elements in one column. So again, take note here that we are looking for the number of elements in one row because this is row-wise, while in the column major, we are getting the number of elements in one column because this is now column-wise, and our index here is J, which is the column index. So this is equal to 2 in our example. And after the column index J, our next consideration is the row index, which is I, and then minus B1, which is the base of I. Let's try to locate the same element that we have computed a while ago. So num02 for column major is this one, located at the 5th position. So let's find out if we get the same value 5. So using now the addressing function formula for column major, which is this, locate num 0, 2, and L sub O is 1 plus our I here is 0 and J is equal to 2. So since that is J, we would use here 2 minus 0 times this is 2 rows or 2 elements in one column plus I is 0 minus 0. So this will simply cancel out. The result now is 1 plus, this is 2 times 2, that's 4. 1 plus 4 is 5. Okay, so we have a consistent result. So this is located at the 5th position. Num02 for the column major is located at the 5th position in the structure, while for row major order, the same element is located on the 3rd position. So in summary, for two-dimensional arrays, there are two ways to order the elements of the array in the main memory or in the RAM. The first is called row major, which is also called row-wise order or the IJ order, where the primary reference is the row. So we take one row at a time, and then when we have listed left to right those elements, we go to the next row, list all the elements left to right, and then go to the next row and so on until you reach the last row. And the second is called column major. This is considering the column as our primary reference. And we call this also JI order. And this is simply taking one column at a time and list all the elements there from top to bottom, and then go to the next column, list the elements from top to bottom, and the next column until you reach the last column. So from our previous demo, we have listed here the elements for this example, a 2 by 3 2D array, and this is our row major order of the elements. And for the column major of the same 2D array, this is the order of the elements. And the first and the last for these two are the same. The first here is num00, the first here is num00, the last here is num12, and the last here is num12. So the first and the last elements are the same, but the in-between are not necessarily the same. And since it's not the same, it also means that we have two different addressing functions. So the addressing function for row major order is not the same as the addressing function for the column major order, because our primary reference here is the row. That is why this is I, and so this is number of rows. And the secondary reference is J. Now for the column major, our primary reference is the column. That's why this is J. And this is multiplied by the number of elements in one column, which is represented by this expression. And from our example, our U1 is 1 minus 0 plus 1. So that is equal to 2, meaning 2 elements in one column, which is equal to the number of rows. And that's why we use 2 here for this expression. Now, the machine or the computer that makes use of this row major order is the Intel-based computers or Intel-based machines, meaning the processor of that machine or that computer is Intel processor.